In this video, I'm going to do two questions, both of them from definite integrals. Now let's begin with the first one. So in the first part, we have to integrate this with the limit as 0 to pi by 2. Now, one thing is very clear that from the question that we are going to put sine pi, sine phi as t. So a differentiation of sine is what? Cos. So cos phi dx is equal to dt. Now, since we have 4 times 5 power, right? 5 cos with fifth power, right? Then we can split it, right? What I'm going to do is I is equal to integration 0 to pi by 2. This is whole under root sine phi. And I'm going to split this cos raised to the power 5 phi as, I'll write this as 1 time cos phi, right? And then this is cos raised to the power 4 times, right? 4 times 5. Now further you can see that I can write this as cos square whole square. All right. I can write this as cos square whole square. Now since we have taken this as sine, we need to convert this as in terms of sine. So what is cos square phi? Okay, I can write 1 minus sine square phi. So I'll be doing 1 minus sine square phi. Well, in your exam, you have to show with the steps involved. I'm doing it as I have to complete in a single screen. Now check here. We can substitute these two with d theta. So now after substitution, well, since we are doing substitution, the limits would also change. Now when x, not x, it's phi. When phi is 0, that is the lower limit, sine 0 is 0, so t is 0. And when phi is pi by 2, that is 90 degrees, sine 90 is 1, so t is equal to 1. So now the limit will change first. 0 remains 0 and 1 will become pi. Pi by 2 will become 1. Pi by 2 will become 1. This is under root t, and 1 minus under root t is what? T raised to the power half, right? So better way to write as t raised to the power half. This is 1 minus t square from here. And these two will club to give you dt. Now it's become easy, and from here we can integrate. But before that, we'll open the brackets. It's going to be what? On opening this bracket, is going to be t raised to the power. Okay, I missed one thing. This has a fourth power, right? So it was fourth power and it was turned as square. So I think we need to first expand this, applying a plus b whole square. So a square plus b square minus 2ab, right? And then we will open this bracket, that is 0 to 1, t raised to the power half. Multiplying this with this is what? 4 plus half is what? 9 by 2. Yeah, 4 and a half. 4 and a half, yeah, that should be 9 by 2 minus 2 times 2 and a half, that is 5 over 2 dt. Now next we are going to integrate it finally. It's what? T raised to the power half, right? So it's going to be what? T raised to the power 3 by 2 into 2 by 3 plus t raised to the power 9 by 2 is what? 9 plus 2, 11 over 2 into 2 over 11. And then it's minus 2, right? There is a minus 2 here. And this is t raised to the power 5 plus 2, 7 by 2 into 2 by 7. And the limit is 0 to 1. So now I is equal to what? If I place upper limit as 1, right? So upper limit, as you know, if I replace t with 1 and 1 raised to the power any number is 1. So what you can get here, that is going to be 2 by 3 plus 2 over 11 minus 4 over 7, right? And minus the lower limit, as you can see that t raised to the power 0 is 1. So everywhere there is t, so it's 0 plus 0 plus 0, which is 0. So finally, we have to find the LCM. So 7 into 3 is 21, 21 into 11, that is 231. So 231 is the 11. And 377 times is this, 77 into 2 is 154. Plus this is 11, 21 times, and 21 into 2 is 42 minus 7. This is 33 times. So 33 into 4. Yeah, that's 132. So that comes out to be how much? 64 over 231 should be the final answer. So this is 4 plus 2, 6 minus 2 is 4, 5 plus 4, 9 minus 3, 6. That's right. So this would be our final answer in this case. In the next question, we have to integrate sine inverse 2x over 1 plus x square, and the limit is from 0 to 1. Now, one thing we can figure out from here that this is in the form of 2 tan theta over 1 plus tan square theta. That means we are going to replace x with tan theta. This implies theta is equal to tan inverse x. And if you find its differentiation, this is dx will be replaced with tan theta differentiation is sec square theta. Now we can also see that we have to change the limit, these two limit. Now placing x as the lower limit when x is 0, right? When x is 0, placing x as 0 over here, theta comes out to be tan inverse 0, and tan inverse 0 is 0. And when placing x as pi by 2, the upper limit here, not pi by 2, this is 1. Placing x as 1, we are placing x as 1, tan inverse 1 is what? Tan inverse 1 is pi by 4. So now the question modifies, and I'll write I is equal to the limit now is, this is 0, not 1. Tan inverse is 0, right? So this is 0 to pi by 4. 0 to pi by 4 sine inverse 2 tan theta over 1 plus tan square theta, and dx will be replaced with this, that is sec square theta. So now I is equal to limit 0 to pi by 4, and this is sine inverse, this is what, sine 2 theta into sec square theta. So we get I is equal to 0 to pi by 4. This will be 2 theta. So I can write 2 outside. So this is clear, right? So this is sine inverse into sine 2 theta is 2 theta. So I'm going to write 2 outside, and this is theta into sec square theta. Now applying by parts, what you can see that we will take trigonometric function before algebra. So this is going to be the first, and this is the second function. This is going to be the second function. So we'll apply by parts here. This is I is equal to 2 bracket first function, then integration of second function. So integration of sec square theta is what? Tan theta. Integration of sec square theta is tan theta minus whole integration d by dx of theta, right? D, not d by dx, d by d theta, right? So d by d theta of theta, right? Which is 1. So I can straight away write 1. And that multiplied by the integration of the second function, which is again tan theta. And we'll have one more d theta. So now, and the limit we will place as the limit we will place at the end, which is 0 to pi by 4. This is I is equal to 2 theta into tan theta minus integration of tan theta is what? Tan theta in positive, it is log sec theta, and in negative, so I'll take negative to make it positive. So this minus and of minus, like what I'm doing is integration tan theta. This is 1 into any number is tan theta only. So integration of tan theta is minus log cos theta. So this minus will become plus log mod cos theta and the limit 0 to pi by 4. Now in the next place, we are just going. Now let's place the value here. This is theta, which is the upper limit, which is pi by 4 into tan pi by 4 plus log mod cos pi by 4. This is the upper limit minus the lower limit. Lower limit is 0. So if I plug in 0 here, it's going to be 0. And what is log 0? Cos 0. Cos 0 is 1, right? So if I show you what I mean to say that this is 0 plus log 1, right? Because why not place it in the next step? This is cos 0. Now check here, I is equal to what? If I open this bracket, so what you can see that this 2 will be multiplied. So 2 into pi by 4 plus what is the value of this, which is 2 multiplied by log. This 2 I'm multiplying. Cos pi by 4 is what? 1 by root 2. So this is 1 over root 2 minus this is 0. 2 into 0 is 0 again. Plus this is log 1 and log 1 value is 0. So know that log 1 is 0. So we don't need to write anything here. So we can say that if I reduce it further, I should get I as what? This would be pi by 2 and minus. All right, this is log. So I can place this using this identity. Where should I do? This is log. N log x is what? Log x raised to the power n. So this is what I'm going to do. I'm going to write log 1 by root 2 raised to the power 2, and which is what? This, which is pi by 2 minus log 1 by 2.